Hey everyone, let us see in this video another sum in application of derivatives, maxima and minima. Okay, now a drum manufacturing company gets an order of manufacturing cylindrical drums without top of high quality steel with a volume of V cubic units. The company wants to make maximum profit by using least amount of steel for making the drums. This is the information. Two questions. Express the surface area of the drum in terms of radius r. Second, find the relation between radius r and height h of the drum if least amount of steel is used. Let us draw a cylinder figure. The radius is given as r and the height is given as h. Remember, it is open at the top. That is very important. Let us write what the dimensions given. Radius is r, height is h, and volume is v. It is given already. Let us take S as the surface area of the drum. V is given here, so that is a constant. That is an important point to be noted. V is equal to, you know the formula for volume of a cylinder, pi r squared h. There are two variables r and h. We have to get everything in terms of r because that is the first subdivision, isn't it? So now h is equal to v by pi r squared. Now, what is the formula for surface area? The CSA is 2 pi r h plus the bottom circle, no? That area is pi r squared because the top is open. So the surface area is 2 pi r h plus pi r squared. In the place of h, now you substitute v by pi r squared. Pi and pi will get cut. 1 r will get cut. You will get s is equal to 2v by r plus pi r squared. Okay, so the first subdivision answer is this. We have expressed the surface area in terms of r and of course v, which is a constant. Okay, in the second subdivision, we have to find the relation between r and h when the least amount of steel is used. Here, what is the concept? The important one is if you want to use the least amount of steel, the surface area of the drum should be least. This is the point you should note. So now your S should be minimum. What is the condition for S to be minimum? ds by dr is equal to 0. The first derivative is 0 for both maxima and minima. The second derivative d square s by dr squared should be greater than 0 for minima. Already you have derived s is equal to 2v by r plus pi r squared. Let us take the r to the numerator so that differentiation will be easy. So s is equal to 2v into r power minus 1 plus pi r squared. So ds by dr will be 2v, constant, take it out. R power minus 1, when you differentiate, you will get minus 1 r power minus 2. Okay? Plus pi r squared, if you differentiate, that will be 2 pi r. Then the second derivative, d square s by dr squared will be minus 2v you take out. 1 by r squared is r power minus 2. So minus 2 r power minus 3. That is the differentiation. Plus 2 pi r, when you differentiate, you will get 2 pi. Let us simplify it. We will get plus 4b by r cube plus 2 pi. This is definitely greater than 0 because r is radius, it will be positive, and v volume, pi, everything is positive and there is a plus sign in between. So the second derivative is greater than 0. That condition is satisfied. Let us equate the first derivative is equal to 0. So ds by dr, that is equal to 0. So you will get 2v into minus 1 by r square plus 2 pi r is equal to 0. Or you will get minus 2v by r squared is equal to minus 2 pi r. You can cut the 2, you can cut the minus sign. Now, in the place of b, you substitute pi r squared h, that is the formula. Then if you simplify, the pi will get cut, the r squared will get cut and all. You will get h is equal to r. So now, if you want the surface area to be least, that is the least amount of steel to be used, what is the relation? H should be equal to R. Do you understand the sum? Thanks for watching the video. Give me a like. You can comment, share it with your friends. Thank you once again.